Welcome to the lecture Introduction to PIC Microcontroller. Peripheral Interface Controller, that is PIC Microcontroller, is an 8-bit microcontroller and it is developed by Microchip in 1989. The PIC family includes 10x, 12x, 14x, 16x, 17x and 18x. All these microcontrollers are 8-bit microcontrollers, so their ALU is 8-bit and they works on 8-bit data. There are a lot of advantages of using PIC microcontroller. Lot of applications are there which we can build using PIC microcontroller. But one major problem is there with this PIC microcontroller, that they are not completely compatible with related to software when going from one family to other family. As you have already studied 8051, we first compare this 8051 with PIC microcontroller family, and we are focusing more on PIC 18X. So we'll compare here 8051 with PIC microcontroller related to few important points. The first is about the ROM memory, that is program memory. So in 8051, the maximum program memory we can interface is 64 kilobyte, whereas in PIC microcontroller we can interface 2 megabytes of program memory. The RAM memory which we are using to store data is maximum of 256 bytes in 8051, but it is 4 kilobytes in PIC 18 microcontroller. There are 3 timers in 8051. So if we consider 8052, then we'll get 3 timers. In PIC microcontroller, the timers are 4. The I/O pins of 8051 are 32. There are 4 I/O ports and each port is of 8-bit. So total pins are 32. Whereas in PIC microcontroller, you'll get 33 or 34 pin, depends upon the version of PIC 18 microcontroller. One serial communication port is available in 8051. One is available in PIC microcontroller. The analog to digital converter is not available internally in 8051, but that is available in few versions of PIC 18 microcontroller. So ADC can be available internally in PIC microcontroller, depends upon the version. So these are the few points which we can compare between 8051 and PIC microcontroller. More points are also there, so that you will understand. We will study the PIC microcontroller in detail. So go through the features, important features of PIC microcontroller. So PIC 16C and PIC 18F are 8-bit microcontroller developed by Microchip. They are high-speed RISC architecture and they are popular due to high performance, low cost and small size. Mostly the instructions are single word instruction. That means size of instruction is 16-bit. So it requires 2 memory location to store one instruction. But 4 2-word instructions are also there. That means size of 4 instructions are 32-bit. These are assembly language instructions of PIC microcontroller. The operating frequency range of PIC microcontroller is DC to 40 MHz. So maximum operating frequency of PIC microcontroller is 40 MHz. The advanced version of this PIC microcontroller includes ADC with 4 channels up to 8 channels. Now the general features of this PIC microcontroller are they include timers, watchdog timers, extended instruction, data memory, serial communication, capture, compare and pulse width modulation block, that is CCP block. Now there are different family members are available in PIC microcontroller. Just go through the comparison of these different family members. Here we are comparing PIC18C, PIC12C, PIC16F and PIC18F family. In PIC10, the pins are 6, PIC12 pin numbers are 8. PIC16F depends upon version, pin number varies from 14 to 40. Whereas PIC18F family members, the pin number varies from 40 to 100. Related to flash memory, RAM memory, so for PIC10 it is 896 byte or 64 byte. Flash memory is 896, RAM is 64 byte. For 12C, flash is 3.5 kilobyte, whereas RAM depends upon the version, varies from 128 byte to 256 bytes. PIC16F, flash memory varies from 7 to 28 kilobyte, whereas RAM memory varies from 512 bytes to 2 kilobyte. PIC18F, the flash memory is 2 megabytes, whereas the RAM memory varies from 32 to 128 kilobyte. The timers in PIC10C, there are 8-bit 2 timers and 2 PWM blocks are available. In 12C, 8-bit 2 timers are available, 16-bit 1 timer is available and PWM 2 blocks are available. In 16F, 4 8-bit timers are available and 1 16-bit timer is available and 2 PWM blocks are available. In PIC18F, 3 timers are available, watchdog timer is also available and PWM blocks depends upon the version. Then ADC channel pins, 4 ADC with 2 channels and ADC is 8-bit. 6 IO pins are there, 3 ADC channels are there and 8-bit channels. 8-bit ADC is available. 12 IO pins are available in 16F, 4 channels for ADC and ADC is of 10-bit. In 18F, depends upon version, 33 to 72 pins are available, 12 channels are available for ADC and ADC is of 10-bit. The additional features in 12C is USART block is available. In PIC16F, watchdog timer, then E port is included, USART block is available, I2C block is available, SPI protocol is available, E2PROM is also included. For 18F version, USB is available, 12-bit ADC is available, USART CAN protocol, I2C and SPI protocols are available. What is new in PIC18 series, that we'll see. The number of instructions more than doubled with 16-bit instructions, enhanced status register, then hardware 8x8 multiply block is there, which increases the speed of instruction execution. External interrupts are more compared to previous series. To prioritize interrupt vectors are available, so we can change the priority of interrupts. Different approach is used for memory structure and because of this the size of memory is increased. The stack is bigger, the level of stacks are more, and user has given more access and control to the stack. The PLL block is used to generate a clock signal. So stable clock can be generated in 18 series. Now how we'll select the PIC microcontroller, which version, which family members we should select for particular application, that depends upon some parameter. First is speed of operation. Depend upon our application, we can check which microcontroller is having more speed. Then how much amount of RAM and ROM is available in that family or in that version. The number of input output port pins are available, how many timers are available, and the number of bits associated with timer, that we have to consider. What is the power consumption of that particular IC, that we have to consider. Availability of tools, whether software is available easily or not, the hardware programming tool for that particular family is available or not, that we have to consider while selecting microcontroller. And if you need added features like ADC, DAC, CPP, can support SPI, I2C, USB, that we have to check in which version it is available, if it is required for our application. Then whether watchdog timer is available, which protects the microcontroller, what are the different modes of timer, what is the size of E square PROM, or whether it is available or not, that we have to consider. Just go through the PIC 18F458. This particular version of this PIC 18F family member, which is a high performance enhanced flash microcontroller with CAN protocol. So the features of this particular PIC microcontroller, it uses 16-bit wide instruction and 8-bit wide data path. So most of the instruction size is of 16-bit. So the 16-bit wide instruction path is used and data is of 8-bit. Program memory in this microcontroller is of 2 megabytes ROM. So to access this 2 megabytes ROM memory, it has 21 address lines. And for data RAM is of 4 kilobytes. So it has 12 address lines. So data lines for data memory, address bus size is 12-bit, and for program memory, address bus size is 21-bit. There is 32 kilobyte flash ROM available, 256 byte data E square ROM available to store critical information. Then 8-channel ADC is available, and this ADC is of 10-bit. So resolution of ADC is 2 raised to power 10. Then there are 5 ports available. Port A, B, C, D, E. Port A is of 6-bit. B, C, D are of 8 bits and port E is of 3 bits. So total 32 IO lines are available. It has capture, compare and PWM modulation module. 3 external interrupt pins are available, and it has 15 bank register with 256 entries, that in detail we are going to discuss. GPR and SFR fixed locations are given for general purpose registers and special function register. For GPR, the locations are variable, and in SFR, for special function registers, locations are fixed. We can assign different priorities to interrupt. Then it has a USART, 3 timers counters, 8-bit and 16-bit timer counters are available. Then it operates up to the frequency of 40 megahertz. High current sink and source is up to 25 milliampere. This is the general block diagram of PIC 18F452 microcontroller. It has ALU that is of 8-bit because it is 8-bit microcontroller. So size of ALU is 8-bit. Then it has working register. Working register is like an accumulator. In almost all operations, this working register is used, and that is called as a W register. Then it has a status register where the flag bits are available, carry flag, zero flag, like that. Then it has a file select register. There is a RAM file register. So number of registers are available in RAM file, and the address will be stored in this file location. Data will be stored. So to select the particular file or particular register, this file select register is used. Then it has brownout reset circuit, watchdog timer, startup timer, low voltage programmer block, debugger block, and there is a timing generation block. So all these blocks you have to study in detail. Then the flash memory program counter is there. Size of program counter is 21 bit because the address bus of program memory is 21 bit size. Then flash memory where we store a program. This program will be fetched, instruction will be fetched and stored in instruction register that will be given to instruction decoder, which will decode this instruction and generates a control signal. Here you can see the mux block, which will select the data from these internal buses, and that will be given to ALU. Then there are counters and timers, IO ports are there, and number of peripherals are also available. So this is the general block diagram of this PIC microcontroller family. We'll just go through each block. So microprocessor unit of this PIC microcontroller includes arithmetic logic unit, registers and control unit. Then instruction decoder. 16-bit instructions are decoded by the instruction decoder. Status register is also there. So in this status register, 5 bits are important. These are the flag bits. Then there is W register, that is working register. Size of W register is 8-bit and which is called as an accumulator. Then program counter register is there, which holds the address of program memory. The address bus size of program memory is 21 bit. Then there is bank select register, BSR register. Size of BSR register is 4 bit and it is used to point to the data memory, and it is generally used in direct addressing mode. So bank select register is a pointer to data memory. There are number of banks, 16 banks are there in data memory. To point to one of the 16 bank, this bank select register is used, which is of 4 bit. Then there is a file select register. It is 12-bit register used as memory pointer in indirect addressing mode. So BSR is used in direct addressing mode, whereas FSR register, which is pointing to this file register, but it is used in indirect addressing mode. Then control unit provides timing and control signal, for example read signal, write signal. Then address bus, 21-bit address bus for program memory. So we can access 2 raised to power 21, that is 2 megabytes of program memory, and 12-bit address bus for data memory. So we can access 2 raised to power 12, but maximum memory we can address is 4 kilobyte. So 2 megabytes of program memory and 4 kilobyte of data memory. This you have to remember. 21-bit address bus for program memory and 12-bit address bus is available for data memory. This is for address bus. Now data bus, 16-bit instruction data bus for program memory, because size of instruction is 16-bit. So to read a instruction from memory, the bus size is kept as 16-bit. But data is of 8-bit, so size of data bus for data memory is of 8-bit. So size of data bus for instruction is 16-bit and size of data bus for data memory is 8-bit. It uses Harvard architecture, so it has separate program memory and separate data memory. So size of buses are also different for data memory and program memory. And control signals, as we have discussed, various control signals are there. The main signals are read and write signal. The program memory address range which user can use varies from 00000H to 007FFH. Data memory 4 kilobytes, so 000 to FFFH. Data E square prom is also there. It is not a part of data memory space, but it is addressed through special function registers. So as we have discussed all this, in this diagram you can check this. It has a ALU registers and control unit. It is a part of its CPU, we can call it. ALU is having W register, working register, accumulator. It is having status register, instruction decoder. Bank select register is there, BSR, which is used in direct addressing mode. File select register, FSR, is used in indirect addressing mode. And there is a program counter register which stores the address of memory location, that is address of program memory location. So the size of program counter is 21-bit. There is a separate program memory and data memory as it is Harvard architecture. So address bus from program memory is 21-bit and data bus for program memory is 16-bit. So generally we fetch the instruction to this bus. Then data memory has 12-bit address bus and it has 8-bit data bus. There are different signals, right? Read signal, write signal, reset is input signal to microcontroller, interrupt signals are there, power, ground, clock signals are there. So this is the general idea about the microprocessor block and its memory. Then this is the program memory block again. So here addresses are shown. Here user can store a data, and this area, uneasy area, if you try to read a data, we can read here 00. For data memory, 12-bit address bus, 8-bit data bus. The addresses varies from 000H to FFH. In 8051, the memory grows in upward direction. That means in 8051, we are writing address, starting address here. And then memory grows in upward direction. That is for 8051. But in PIC microcontroller, the first address is written at the top and memory grows in downward direction. So that is different. The next is detail about data memory bank. So whole data memory, 4 kilobyte data memory is divided into 16 bank. So these banks are numbered as 0, 1, 2, 3 up to bank F. So each bank will have addresses from 00H to FFH. So 256 byte are available for each register bank. So addresses are given, address will start from 000H and then last address is FFFH. So each bank will have this address from 00 to FF, and these are the addresses for overall banks start from 00H to FFH. Now this memory locations user can use to store any data, but the bank number 0 and bank number 16, they are divided into two parts as it is shown here. This is the upper part for bank 0 and this is the lower part for bank 0. Similarly here this is upper part and this is the lower part. So upper part of these two banks are used for a general purpose register. So we can store a data as we can store in all these banks. So in this upper part also we can store general purpose data, but in lower part we can store a special function register. So the lower parts of both these banks are reserved for special function register. The lot of special function registers are available in PIC microcontroller associated with various blocks of PIC microcontroller. So this memory part is available to store a special function register. Now to address this register bank in direct addressing mode, this BSR register is used. This is 4-bit register and this register holds the address or number of this bank. So 4 bits are sufficient to store number of 16 bank. So if you want to point to bank 0, we can store here 0000. Similarly, if you point to bank F, we can store here 1111. To point bank 3, we can store 0011. So address of particular bank will be stored in BSR register. So BSR register is used to point to particular data memory bank. Now about the program memory. Here the program memory is shown. Then PC register, which is of 21 bit, is used to point to the particular memory location of this program memory. The upper memory locations are reserved for the interrupt. So 000H is reserved for reset vector. For high priority interrupt vector, this address is reserved. For low priority interrupt vector, 0018H address is reserved. And then there are memory locations where user can store a program. For this memory locations, if user try to read or controller try to read a data, it will read a logic 0. Then there are different stack levels available. The 31 stack levels are available. It depends upon a version also, but generally 31 stack levels are available and user can use this stack levels or stack memory to store temporary data. The different registers are associated with this stack. So this is the general architecture of program memory of PIC microcontroller.